Hey everybody, it is the last day of April 2025. It is Geo-Rant time, Geo-Rant number 228. It's a nice day out. It's overcast, high overcast, with blue sky poking through. It's probably about 60-ish Fahrenheit, something like that. So I just want to do a little rock identification, or looking at this rock in general for you, because I know you guys like that. But at first, I just want to say, sorry it's taking me so long to get back to comments. This project is wrapping up the first phase of it right now. They're just taking equipment away, and I'm just watching them, babysitting. Okay, so that's why I'm doing this right now. Anyway, look at this rock. We're going to do this one. I actually found it sitting in somebody's not rock garden, but, their pebbles they got in their yard. And I asked the homeowner if I could have it, and they said, sure, take it. They don't care. Now, this is obviously a pebble. So it came, and it isn't from this area, obviously. It came on either a bed of a truck or in a bag. It's for where that came from, who knows? But this is a pebble, but it has little clasts in it, you can notice. Now, first we're going to look at this rock and try to identify it, just from being very limited in what we can do, and I'll tell you the stuff I did with it. I had a metal nail in here, and for the life of me, I don't know where it is right now. But first thing you notice about this, and the color's pretty much coming through on the camera, is the color. Color and just general patterns within the rock texture is what we tend to notice first. And that's also what made me pick this up. Now you look at it, you see this reddish gray or purplish gray color, and that would be due to iron in it. Now, the question is this darker part igneous or is it sedimentary? Now, I did look at it with a hand lens, so I know. But if I didn't have a hand lens, I could tell you it's sedimentary, or at least if this is igneous, it's something like ash, okay? But it's pretty much quartz in here, making this up, the dark part, other than the iron in it, coloring it. So it's not, just to tell you, it's not, like an ash or anything like that. It is definitely sedimentary in origin, because we have this old saying in geology, ash is igneous on the way up, sedimentary on the way down, yet we consider it igneous. So yeah, igneous on the way up, sedimentary on the way down. But you could just look at it and you can tell it's bedded. So it's been transported. And so the matrix, I'll just say matrix, or the dark part, okay? That is definitely sedimentary. And like I said, I look at it on a hand lens. It's very fine grained, and it's mostly, I can't even see the individual grains, most of them, with the hand lens, which tells me it's mostly made of clay. What I can see is quartz, and it's silt sized. So that would tell me that, this is a shale, essentially. Now, this is metamorphosed, so it's a slate or phyllite if you want. Okay, so you look at it, though, and you see there's these angular pieces in it. Now, I can tell you they are not carbonates, even though they're lighter, because I don't have acid, but that nail I have should have scratched it if it was, and it did not. So it's silica. It's a quartzite. It is very it's microcrystalline, but you can see the crystals with a hand lens. So it's not, that fine crystalline, but it's basically a metamorphosed siltstone. These lighter particles within a slate body. Now, remember the difference between breccia, and this is a breccia, the difference between breccia and conglomerate is the relative roundness of the clasts. Okay, now these are pebble sized. Pebbles don't mean round. It's a size. It's on the Wentworth scale. That's all it is. It has nothing to do with composition. It has nothing to do with shape. Okay, so these are little pebbles within a bigger pebble, and this is a pebble too. Okay, even though that one's more rounded, but it's brecciated. All right. Now, I cannot tell you the exact origin of this rock. I can't even tell you where it's from, but it's got to be from north of, I want to say Wausau. It could even be from Wausau area, because you do see this type of brecciation in sedimentary rocks near quartzites in certain parts up north. So, and it locally occurs too. It occurs in the Gunflint Formation. It occurs on some of the metasediments around the Wausau terrain. It occurs in some banded iron formations, although this is not banded iron, although it has a lot of iron in it. This is kind of heavy for a pebble. So, but it's still not banded iron. And you can have quartzite in your banded iron. Matter of fact, the way I classify in my book, the way I classify banded iron formations, if I have the book, has nothing to do with their, like, you know, is this they're iron stones. But it has to, I classify them based off of their ferrous, their iron, their silica, and their carbonate content. And it's a ternary plot. I don't seem to have my book at the ready. Otherwise, I would show you. So I will put a link to the book below if you want it. It is not a, just remember, if you buy the book, it is not a teaching guide. Okay, it's a basic petrology book. If you know enough about grain sizes and stuff like that, you'll be able to, you know, use the book. But anyway, there's something else I want to go over here. So basically, this is just a, it's a, I would call it a slate breccia with quartzite clasts, is the simplest way I would put this. Now, I would obviously go into more detail, because I would put the color down. I would put the bedding down. Now, you look here, this is another, you know, reason why you know it's sedimentary, is because it has bedding. Okay, now, yes, you can get bedding in igneous rocks. Matter of fact, there's places near Duluth that show that exact thing, that show that exactly. But anyway, I digress. Now, we're going to look at something here. Now, you can tell by you rotating this rock where bedding is. It's tabular. It's mostly horizontal. There's some minor cross bedding or cross laminations in it. It's laminated more than it is bedded. Now, okay, so you can tell because you can see this whole rock, but what if this rock was on a cliff face and this is what you see? You might look at it and be like, oh, there's some anticline here, and the beds, your brain wants to make these beds horizontal because that's how you're taught as a geologist, okay? But we know stuff can be turned over. This is why taking measurements is important. It's so much more important than just looking at something at a distance and going, oh yeah, ooh, ah. Because if I didn't know this was turned vertical, I would assume this is bedding. But if we look around, so if this was turned vertical, I would have to take a series of apparent strikes and dips to get the true strike and dip. Okay, then I can plot it on a stereo net, do a 3-point problem, or do it mathematically. Okay, so this is not, the bedding does not form an anticlinorial structure. See, your brain can be fooled. All right, and they actually, in the Baraboo class, in one of the quarries, the structural geology class, ISU, there's a quarry with something that looks like an anticline in it, and it's an optical illusion. Okay, you get your butt up there and look at it and measure it, and you can tell the strike and dip is the same as the other stuff around it. It's just an optical illusion. So yes, your eyes can be fooled. That's why we take measurements. But anyway, yeah, you can see the lamination. You can see the bedding. Laminations are beddings. They're just really small ones. And even though this is angular, it's still considered a pebble. But this is a breccia. It's brecciated, I should say. Now, what probably happened, this isn't part of the Sudbury impact. I've been able to look at it with hand lens enough to know it is not that, okay? But this is probably a storm rip-up somewhere. Anyway, that's it. If you have any questions or comments, please leave them below. I hope you learned something.